Hi guys, today we're going to be talking about scientific notation, and we're actually going to be addressing two learning goals in this video. I can convert between the decimal form of a number and scientific notation, and I can compare numbers written in scientific notation. Let's get started. So first of all, we want to go over what are the rules for scientific notation, or what does a number that's written in scientific notation look like. Here are the rules that we need to think of when we're thinking about a number written in scientific notation. It's going to have two parts to it. A number written in scientific notation will be factors multiplied together, two factors multiplied together. The first factor should be a number that falls between 1 and 10. So anytime you have a number written in scientific notation, the first number has to be between 1 and 10. And the second factor should be a power of 10. So the base will be 10 and the exponent can be any integer. Let's look at how we do that. If I want to take a number that's either really big or really small, which is usually when we use scientific notation, these are the steps that I'm going to use to change that number into scientific notation. I'm going to take the decimal point in the number and move it so that the number is between 1 and 10. So I'm just going to simply move the decimal point until I get a number between 1 and 10. Then I'm going to count the number of places the decimal point moved and make that the exponent on the power of 10. If I moved my decimal point to the left, then my exponent is going to be positive. If I had to move my decimal point to the right to make a number between 1 and 10, my exponent is going to be negative. So let's see what that looks like. Here are two numbers. One is a really big number and one is a really small number. So if I want to take this first number here, 15,800,000, and I want to write it in scientific notation, I am going to take my decimal point, which is right here to begin with, and I am now going to move that decimal point all the way over so that I get a number between 1 and 10, which should be right here. So you can see that 1.58 is between 1 and 10. And usually always, when you have a really big number, you're going to be moving your decimal point all the way over so that you only have one digit to the left of the decimal point. So now I need to count how many places did I move my decimal point. So I'm going to first write this number that's between 1 and 10, 1.58. And if these numbers here had not been 0, oftentimes I will round this number, the first factor in my scientific notation number, so that I don't end up with something that's a whole bunch of digits long. So I could have rounded that. I could even do that now. I could round it to 1.6 if I wanted. Then I'm going to have times 10 to some power. And my power is going to indicate how many places I moved my decimal point. So I am now going to count. I moved it 1, 2, 3, 4, 5, 6, 7 places. So it started at the very end. I moved it 7 places. So my power is a positive 7 because I moved my decimal point to the left to get that number written into scientific notation. Now I'm going to look at this second number. This is a very small number, and so when I move my decimal point, I can see it's right here, and I am now going to move it over to here so that again I'm getting a number between 1 and 10. So my number now, my first factor in writing this in scientific notation, is going to be 7.3. That's my number. It's in between 1 and 10. And then I'm multiplying here, so because I have two factors, and I know that I'm going to have 10 as my base. Now I need to count how many places I moved my decimal point in order to figure out what the power is. So I can see I moved my decimal point 1, 2, 3 places, and I moved it to the right. So if I look at that rule, that means that my power is going to be a negative 3. So that is how you write numbers in scientific notation. You just follow those steps. What if I have a number that's in scientific notation and I want to write it in standard notation as a regular decimal number? I'm going to look and kind of just do things backward from what I did to put them into scientific notation. So I'm going to look, and I have a positive power here, positive 5. I'm going to take this number 7.01, and I'm actually going to move my decimal point 5 places to the right because I want to undo that. And a positive power tells me to move 1, 2, 3, 4, 5 places to the right and just fill in zeros here where I have extra places. And so I'm just going to put in commas where I need them. And you can see that 7.01 times 10 to the 5th power is the same as 701,000. If you have a positive power on your 10, you should get a bigger number than what you started with. So your number should be bigger than 7.01. Now if I look down here, I have a negative power. So again, I'm going to take my decimal 7.01, but now I'm going to move my decimal point 5 places to the left. A negative exponent tells me to move my decimal to the left. 1, 2, 3, 4, 5. Put a decimal point right there, and we're going to fill in zeros here. So you can see that what I ended up with, if I write this more neatly, is 0.00000701. If you have a negative exponent on your scientific notation number, you should end up with a number that is smaller than what you started with. So this is significantly smaller than 7.01. They're equal, excuse me, when I say smaller, I mean smaller than the first factor. These two things mean the same thing. Those are equal. These are equal to each other. They're just different forms of writing the same number. Okay, so how do I compare two numbers written in scientific notation? If I'm comparing two numbers that are written in scientific notation, the first thing I want to look at is the exponents. If the exponents are different, the only thing you have to look at is the exponent. Whichever one has the bigger exponent is the bigger number. Keeping in mind that positive numbers are always bigger than negative numbers. So if you have a positive exponent and a negative exponent, the scientific notation number with the positive exponent is larger. If the two exponents are the same, then I'm going to look at the first factor. And again, it's just whichever one's bigger is the bigger number. So if I write two examples, two numbers written in scientific notation, 7.5 times 10 to the 3rd power and 9.1 times 10 to the 6th power. And remember, we said that number one, we compare the exponents. So I'm going to look at these two exponents. They are not the same. So I know that the number with the bigger exponent is the bigger number. So this is the bigger number. No matter what those first factors are, all I have to do is look at the exponents. So if I have two numbers here and I look at them, they're both in scientific notation, I'm comparing the exponents. The exponents are the same. So I'm going to go to step 2 and compare the first factor. I'm going to compare 7.3 to 5.84. 7.3 is larger than 5.84. So 7.3 times 10 to the 4th power is larger than 5.84 times 10 to the 4th power. It's as simple as that. Here are your free response and multiple choice questions. So go ahead and pause the video now and answer those. And after you're done, have a fabulous day. Bye-bye.